you to that first page in your notes. You will notice that today we are doing problems from the textbook. So the assignments are up for the week. This week we do 2 different assignments from your textbook on Tuesday and Thursday, and not this one on Friday, because the F3 worksheet is long. So, what is an exponent? So here we're looking at 0 and negative exponents. Some of you might remember this from last year. What is an exponent? So please tell your shoulder partner to be ready if I call on you. What is an exponent? This, 3 to the 4th. Which one is the exponent? 4. The 4 is our exponent, right? So if I'm looking at my exponent, that's my 4. And what does the exponent tell us? Want to say it a little louder, Kevin?
How many times you multiply 3 by 3?
The exponent tells us how many times to multiply, right? And in this case, it's telling us how many times to multiply the base, which our base is 3, and we are going to multiply it 4 times. So keeping in mind that this is telling us 3 times 3 times 3 times 3. So the exponent is telling us the number of times that we're multiplying. Okay? So what I'd like you to do is looking at that table in that next part down in your notes. No calculators. 2 to the 4th. Now, it might be easiest to start with 2 to the 2nd. 2 to the 2nd is 4. And 2 to the 3rd, 8. Right? Start filling your table in as much as you can. Again, 2 to the 1 is 2. So you might see a pattern going down like what's happening. 10 to the 2nd is what number? 100. And we have 10, right? 10 to the 3rd is 1,000, and 10 to the 4th is 10,000, right? So here, 2 to the 4th was 16. What's happening each time as we go down? We're divided by 2. So 2 divided by 2 means 2 to the 0 is 1. And 1 divided by 2 means 2 to the negative 1 is 1/2, right? 1 divided by 2 is 1/2. Could you have the decimal point 5? You could. And now if I take 1/2, and I'm always, if we're looking for the pattern, in the 2x, the pattern was to divide by 2, right? As you go down the table. So if I take 1/2 and I divide it by 2, what do I end up with? 1/4. And someone said, well, can I have for these last two, could I have had 0.5? Yes. And 0.25? Yes. So if we continue with that same one on this side, what's happening in our 10 to the x? What is our pattern? Please tell your shoulder partner. So if we are going down that table, what is the pattern? So I want to share what they and their partner came up with. Raise your hand, please. What you and your partner discussed. Yeah.
Divide by 10.
Divide by 10. Anyone have anything else? If you're going up this table, you're adding a what? A 0. That's the same as multiplying by 10, right? If you divide by 10, you're actually moving that decimal point always back 1. So this should be 1. This should be 1/10 and 1/100. Okay? So the pattern is to divide, we would say, by 10 as we go down. Okay. And some of these rules, you might remember some that you might have. Did you read Exponents of pre-algebra? You guys do some exponents of pre-algebra. A little bit, and so too. So, here are some of your properties that, yes, you need to memorize. Top of that next page. So the first one is exponent of 0. The property says every non-zero number a raised to the 0 power equals 1. 6 to the 0 equals 1, negative 24, all in parentheses to the 0 power equals 1. When is it equal to a negative 1? When you have a negative and it has something like 6 to the 0. And the reason that this one will be different is that this means a negative 1 times 6 to the 0. That's what this means. When you look at this part, negative 6 to the 0 really means negative 1 times 6 to the 0, which would leave us with a negative 1. If there's a parenthesis, though, it's understood that anything, that whole thing raised to the 0 is a positive 1. It doesn't matter if it's negative or not. So you just need to be really clear with how you put things in your calculator and if it means that it's going to be a negative 1 or positive 1. The other thing the negative tells us, every non-zero negative, for every non-zero number a, the integer n, a to the negative n, is equal to 1 over a to the n. And the key thing that we are really looking for here, anytime we have a negative exponent, is we are talking about that it is the word I would like you to write here is reciprocal. And a lot of times I'm going to ask you to apply these rules, which will mean I don't want you to give me a decimal for 7 to the negative 3. So some of you in that table that put 0.1 and 0.01, 0.5 and 0.25, I'm going to ask you to leave it always as a fraction when we are doing our homework. Which means if we have the negative exponent and it's in the numerator, because that's where this one is, right? Because we can think of a to the negative 1, a to that negative n over 1. If it's in the denominator, so if I have something like 1 over a to the negative n, write this down, that would be equal to a to the negative n, if that's in my denominator, is going to be equal to a to the n in our numerator. So it simply means, keyword, reciprocal. Reciprocal is what that negative exponent does. So if we're looking at 7 to the negative 3, we're going to rewrite it as 1 over 7 to the third. 4 to the negative 2, 1 over 4 to the second. 4 to the second is 16. My answer is going to stay as 1/16. 3 to the negative 5, if I'm looking at that. 1 over negative 3 to the 5. Will this be positive or negative? How many negatives are we raising to the 5th power? 5 of them. So since I have 5 negatives being multiplied together, my answer is going to come out to be negative, and 3 to the 5th is 243. So simplifying exponents this video. It's not too long. It's they kind of walk through some of these rules. And I better make sure I have my speaker plugged in.
What is the value of 1 divided by 5 to the negative third? What's your guess? In this lesson, we will learn how to simplify expressions involving negative exponents by applying exponent rules you already know. Remember, any base raised to the exponent of 0 is 1, and any base raised to a negative exponent is equal to 1 divided by that base raised to the opposite, or positive exponent. Also, to divide a fraction, a over b, by a fraction c over d, you would multiply a over b by the reciprocal of c over d, which would be d over c. Back to our original question, what is the value of 1 divided by 5 to the negative third? Since a negative exponent indicates our base will move to the denominator with a positive exponent, we now have 1 over 5 to the positive third. It may seem odd at first to have a denominator in our denominator, but when we remember that fractions can represent division, we can think about this as 1 divided by the fraction 1 over 5 to the third. And to divide fractions, we multiply by the reciprocal. So we have 1 times 5 to the third over 1. This results in 5 to the third. So we've answered our question. 1 over 5 to the negative third power is equal to 5 to the third power. We could also look at this as 5 to the third power over a denominator of 1. This will help us in our next step. So when we see 5 to the negative third in the denominator, it results in 5 to the positive third in the numerator. And when we see 5 to the negative third in the numerator, it results in 5 to the positive third in the denominator, with a 1 in the numerator. Here I want to illustrate a way to remember this idea by imagining the numerator and the denominator of a fraction as two levels of a building, with a locked staircase in between. If we start with a base raised to a negative exponent in the numerator, we can look at the negative exponent like a key to the locked staircase. The base uses the key to travel downstairs and is now in the denominator. It's very important that the base leaves the key in the door, so that when it arrives in the denominator, it no longer has a key. It no longer has a negative exponent. It's also important to realize that since the base is now in the denominator and there is nothing in the numerator, we have to leave a 1 there to indicate we are dividing by b to the power of a. So let's look at this when the base starts, the base with the negative exponent starts in the denominator. Again, the negative exponent serves as a key for the base to unlock the staircase and travel up. The base leaves the key in the door, so it no longer has a negative exponent once it arrives in the numerator. Now there's nothing, so it no longer has a key there. Now that there's nothing in the denominator, we can put a 1 there, but since that indicates we are dividing by 1, and dividing by 1 will not change anything, we do not have to put the 1 there. So let's try a few examples. This example asks us to simplify 2 to the third raised to the negative third divided by 2 to the fifth. When we are dealing with negative exponents, I find it easier to look at any division in fraction form. So let's write it like this. Since in the numerator we are raising an exponential expression to an exponent, we multiply the two exponents. So we'll multiply the 3 times the negative 3 and get 2 to the negative 9th power. Now we have a negative exponent in the numerator. So this 2 has a key to use the staircase and goes down into the denominator with a positive exponent. Now since there's nothing in the numerator, we'll go ahead and leave a 1 there. And now in the denominator, we're multiplying two exponential expressions, so we'll add the exponents and get 1 over 2 to the 14th power. Let's examine this step a little more carefully to see a common mistake. Sometimes when students see any negative exponent, they want to flip everything they see. They'll send anything from the numerator to the denominator and anything from the denominator to the numerator. But exponents should be applied only to the base to which they are attached, so we do not do this. Only the bases that have negative exponents, here, the one in the numerator, will change levels. The bases with positive exponents will stay where they are. Let's do one last example. We want to simplify x to the third times y to the fourth divided by x to the third times y to the negative third. So here we have x to the third in both the numerator and the denominator. You could either subtract the two exponents and get x to the 0 power, which is 1, or you could visualize a series of x multiplied by itself 3 times in both the numerator and the denominator. Either way, all those x's will divide to 1 and have no further bearing on our multiplication problem. So we'll just cross off both of those x to the thirds.
So that's kind of like
now we see that
just
y to the
one
negative
look at
y to
it.
the third is in the denominator. It has the key to rise into the numerator and join the y to the fourth that was already there. Now we have y to the fourth times y to the third. We'll add those exponents and get y to the seventh as our final answer. In this lesson,
So when you're thinking about all of our exponents and we're thinking about our rules, so on that next page in your notes, going down, we want to apply our rule. And when we look at our answers, we're always looking at our answers, staying with no negative exponent, okay? So always one of the key things that I want to see when we do ours is no negative exponent. So if it helps to think of x to the negative 9, we could actually think of that as being over 1. So when we look at that, my answer is going to be 1 over x to the 9. This whole fraction is our answer. Here our negative 3 is in the denominator, n to the negative 3. So again, using that concept of unlocking it to move it to the numerator becomes n to the third over 1. Do we have to put it over 1? No, you can just leave me an answer as n to the third. Here's where the most confusing thing happens is if we look at this problem, 4ac to the negative 3 and b. I will have people want to move everything to the denominator. What is the only thing that has a negative exponent? Only the c. So the 4 is actually to the first power, even though they don't write that there, and the b is actually to the first power. So the only thing that is going to be moved is our c will be moved to the denominator. It will become c to the third. Our 4 stays in the numerator, and the b stays. And so my final answer is going to be this fraction where I have no negative exponents. Okay? So the key thing is no negative exponents when you're asked to simplify. If I look at this next one, please try the last two right now. Kind of check with your shoulder partner as you are doing those. And it's 2 times a, don't have to put it over 1, but you could. 2a to the third. For the next one, if we are looking at that next one, Whitney and Jacob, what do you guys have? You guys thought? How do you compare? You don't have it done.
I kind of just went 1 over
m to the second, n to the fifth, and 1 is in the numerator. Yes. So we are not going to move the m. It wasn't negative. The only thing we're moving is the negative exponent. It goes to the denominator. Everything else stays where it's at. Okay. The next part that we want to take a look at is where we are applying. So in your homework questions, you're going to have some of these applied questions. So this one says the population of bacteria is doubling every hour. Under controlled laboratory conditions, the number of bacteria can be modeled in the expression below, where H is the number of hours the scientists are measuring the population size. It says evaluate the expression for the given values below and explain what it represents in this situation. So this 2 is because it's doubling. The 1,000 is because that's how much we started with. So we are going to substitute, just take your calculator if you like, 1,000 times 2, and you're going to take it to the second power. Or, you wouldn't even need your calculator for this, right? 2 to the second is 4, and 1,000 times 4 should give us, so we should have 4,000. And in this case, if I'm looking at this answer, what this answer is telling me is that I'm going to have 4,000 bacteria after 2 hours. So the key thing I want to write down is that I will now have 4,000 bacteria after 2 hours. So that next one is telling us, okay, H is to the 0 power. So if I'm substituting in, I'm going to have Josie 1,000 times 2 to the 0. Micah, anything to the 0 power equals 1. So I'm going to have just 1,000 for my answer. So if I'm looking at what does this mean, it means that 1,000 bacteria were measured for our population. And sometimes people will write down at the beginning of the experiment or at time 0 at the beginning of the experiment to signify the 0, right? And if I'm looking at that last one, Mallory, tell me what I should write down to substitute in. I'm going to have 1,000 times 2 to the negative 3. And remembering that that 2 to the negative 3, that actually is going to mean 1,000, and we could write it as divided by 2 to the third, right? Making our negative exponent positive. 2 to the third is what? 8, so that really means 1,000, and if you wanted to just divide by 8, 1,000 divided by 8, if we are looking at that answer, gives us 125. So 125 bacteria 3 hours before they measured the population. Sometimes people like to write before the experiment started. Anything along that line would work, okay? But you want to make sure that you're noting that negative 3 was like before in time. This time, they're telling us the insect population is 5,400. So if we are writing this, we are going to start with our 5,400. And the first time we're going to use W equals -2, so we're going to put times 2 to the -2. The next time you're going to tell me 5,400 times, oops, excuse me, not 2, 3. Thanks, you're going to have to catch me working, Maria, thank you. Times 3 to the 0, and then you're going to put 5,400 times 3 to the first power. Please tell me what each of those are equal to. You can put them in your calculator. Over 3 to the second, which just means 5,400 divided by 9. So you probably don't need your calculator, right? 5,400 times 1 and 5,400 times 3. The first one, Lainey, what'd you get?
I don't know if this is right. I don't think it's right. It's 600.
So you take 5,400 divided by 9. Or you could do it with, did you do it with the 3 to the power? Same thing, right? So the question was, if I put it in my calculator, 5,400 times 3 to the negative 2, I get 600. And I get the same answer doing it this way. So yes, I know you can use your calculators. What I'm going to be asking tonight in your homework is that when you have this problem written, that you'll rewrite it with a positive exponent and tell me your answer. I don't want you just plugging it in your calculator. I want you to make sure you're knowing the rules. So we have 5,400. And then our last one, Ben, what'd you have?
16,200.
16,200. And it says, what does each value of the expression represent in the situation? So this is what we want to be thinking about. What does the 5,400 tell us in the original problem? What does that 5,400 tell us in our original problem? 5,400, if we are looking at that. So the insects, there are 2 weeks before it was measured. It was when it was measured right at the beginning of the experiment time, and 1 week after is when it was measured. So that's what the significance of our -2, our 0, and our 1 mean. 2 weeks before, when it was measured, right at the start, and 1 week after. The 5,400, that is our starting insects, right, that we have to start in our experiment. What does the 3 tell us? What does the 3 tell us? Please tell your shoulder partner right now. What is the 3 telling us? So, the 3 tells us that I heard the word triples. And if we're talking about it tripling, we're talking about it tripling how often? In what time period?
A week.
It is in the week. So we're talking about it being a triple if we are looking at this. So when you are looking at it, that it's going to triple every 3 weeks. Or triple every 1 week. Okay? So your homework that you are looking